In this lesson, we're going to look at the sum and difference of cubes and how we can use patterns to factor them. So first, let's look at some familiar factoring patterns. This first one here is the difference of squares, which we looked at when we looked at special patterns in factoring. And we can see in order to factor this one, we would take the square root of this term and write it here and here. Take the square root of this term, write it here and here. And because we have no middle term, that means that our middle terms must cancel out. And the only way to do that is to make one a plus and one a minus. And if you need some review of that, you can look back at the previous lessons on factoring. Here's a second type. In that same special patterns lesson, we also looked at perfect square trinomials. Perfect square because it's the same binomial multiplied by itself. So we're squaring this a minus 3 to get this trinomial. That's why it's called a perfect square trinomial. But now going backwards, if we're given this form and we have to write it in factored form, we take the square root of the first term, and that goes here and here. Square root of the last term goes here and here, and the sign of the middle term tells us which sign we need to repeat in both sets of parentheses. Now there were some other specifics that we have to look for to make sure that this is indeed a perfect square trinomial. So again, if you're not sure of what to look for to determine whether or not it's a perfect square trinomial, then please look back at that lesson. It was 2 lessons ago. And then in the last lesson, we looked at trinomials that are not special pattern trinomials, but that are easily factored by finding 2 numbers that multiply to be C and add to be B. So our value of C is negative 56. Our value of B is negative 1. And if we're looking for 2 numbers that multiply to be negative 56 and add to be negative 1, then negative 8 and positive 7 fit the bill. So those are the types of factoring problems that we've looked at up to now. Today we're going to look at a different pattern called sum, or in this case difference, of cubes. We're going to start out with the difference of cubes pattern, and if we look at this binomial, well, you might be looking at this saying, oh, but that's a perfect square, that's 8 times 8. But 64 is also a perfect cube because it's 4 times 4 times 4. And x cubed is a perfect cube because it's x times x times x. So let's look at how we would factor this. This is what it factors to. But before I explain how to get from the binomial to its factored form, let's just check it out, multiply everything out, and make sure it does indeed equal x cubed minus 64. So I'm going to start with this x, and I'm going to distribute. X times x squared will give me x cubed. X times positive 4x will give me positive 4x squared. And x times 16 will give me a positive 16x. Now I'm going to take the second term in that binomial that's out in front, and distribute that. And so now I'm going to distribute the negative 4. So negative 4 times x squared gives me negative 4x squared. Negative 4 times a positive 4x gives me negative. Let me get rid of that. Gives me negative 16x. And a negative 4 times a positive 16 gives me negative 64. So as we saw with the difference of squares, we have middle terms that are going to cancel out, and we're just left with x cubed minus 64. So it does work. When we multiply this out, we do get x cubed minus 64 back. So now let's just take a closer look at this pattern and see if we can figure out what's going on. Well, what I see right away is much like the difference of squares pattern where I had to find the square root of the first term and the square root of the second term. Here I have a difference of cubes. So it would be helpful if I could find the cube root of the first term and the cube root of the last term. So the cube root of x cubed is going to give me x. And the cube root of 64 is going to give me 4. So I notice right away that in my first binomial, I have these two values. I have x and I have 4. And the sign in between them matches the sign in between my two original terms. So that part is pretty easy and pretty clear to see. I take the cube root of this first term, which is x, and that goes here. I take the cube root of this number, which is 4, and that goes here. The sign in between them is the same as the sign that I originally started with. Now let's look at the trinomial, which is the second part of the factored form. If I take this first number here, this x, and I square it, then I get this first number here. If I take this number, this -4, and I square it, I get this number here, +16. So that's how I get the first term and the last term. But what about the middle term? Well, you might notice that if I were to multiply these two together, I would get -4x. And that's close, but this is a +4x in my middle term. So I take the opposite of their product, and that gives me the middle term. Now, I know that's a lot to remember. We're going to look at a bunch of examples, but let's just look at it one more time. I took the cube root of x cubed and got x. I took the cube root of 64 and got 4. So that gave me my first two values. X goes here, 4 goes here, and the sign that I started with, the minus, is the sign that's in between. Then from here, I square this value, and I get my first term in the trinomial. I square this value, and I get the last term. And then I multiply and take the opposite to get the middle term. Now, we can generalize this pattern using variables, and that's what's happening here. This is just a generalization that can help us remember so that you don't have to memorize the pattern. But what this is showing is that I take the cube root of this term, and it's right here. I take the cube root of this term, it's right here, and my minus sign stays a minus sign. Then I square this term and put it here, square this term, put it here, I multiply and take the opposite and put it here. Same thing happens with the sum of cubes. Although we didn't look at any of those yet, it's the same pattern. I take the cube root of a cubed is a, cube root of b cubed is b. The sign that I started with is the sign for my binomial. Then I square this, it's right here. I square this one, it's right here. I multiply these two terms together and take the opposite, and it's right here. So just because I have a sum of cubes, it's no different, or the pattern at least is no different from the difference of cubes in terms of how we arrive at our factored form. So I put the two patterns up here just for reference so that we can remember that that first term matches the first sign, the minus sign matches the minus sign that we're given, or in this one, the plus sign matches the plus sign that we're given. Just as a reminder, and just for reference, the patterns are up there. But now let's do some. Let's actually factor these sums and differences of cubes. So the first one is x cubed plus 27. All right, so I need to find, and I'll write it above just so that I don't run out of room. I need to find the cube root of this term and the cube root of this term. So the cube root of 8x cubed, remember I'm thinking of some number times itself times itself. So in order to get 8, if I'm thinking of some number times itself, that would have to be 2 times 2 times 2. So 2 times 2 times 2 is 8. So the cube root here is 2. The cube root of x to the third is x. With the 27, I'm thinking of some number times itself times itself. Now right off the bat for this one, you might be thinking, well, that's 9 times 3. But remember that 9 is 3 times 3. So in order to get 27, we have to do 3 times 3 times 3. So that means that 3 is the cube root. So now I'm ready to fill in my pattern. I know that I'm going to have 2x plus 3 to start us off because I'm taking this term, I'm taking the original sign, and I'm taking this term, right? That's the first part. Now to get the next part, I have to square my first term, so that would give me 4x squared. I have to multiply them together and take the opposite. So the opposite of positive 6x would be minus 6x. And then I have to square my 3 to get 9. And I'm done. All right, pretty simple. And remember, you don't have to memorize anything. You can use these patterns to help you remember what to do. So let's look at the next one. The next one we'll look at is 125x to the third minus 216. So 125, I have to think of some number times itself again. That gives me 125. And I know that in money, $1.25 would be if I had 5 quarters. So 5 times 25 is 125. And I know 25 is 5 times 5. So all of this just to say that the cube root is 5. And the cube root of x cubed is x. Now if you're not sure, you can always use your calculator to find the cube root. On the other side, I've got 216. Well, 216 is 36 times 6. And 36 is 6 times 6. So my cube root here is 6. So now let's fill it in. I know I'm going to have a binomial here, and I'm going to have a trinomial here. So in my binomial, I'm just going to use these cube roots that I found, 5x and 6. And I'm going to use the original sign in the problem, which was a minus. Now to get my trinomial, I'm going to square that first number in the binomial to give me 25x squared. I'm going to do the last term here. I'm going to square my last term, or square the negative 6 to give me positive 36. And now to get the middle, I'm going to multiply these together, which is negative 30x. And take the opposite. And I'm done. All right, let's look at the third one here, which is 2x cubed minus 128. Now, you might be looking at the 2 and thinking, oh, what am I going to do with that? Because that's not a perfect cube. But I noticed that both of these terms are even. So that means I could factor out a 2, and I'd be left with x cubed minus 64. And this is the original example we looked at, x cubed minus 64. So let's do it. I take a 2 out front. I just write it out front because I factored it out. Now I'm going to have my binomial and my trinomial. I'm going to use the cube root. The cube root of x cubed is x. The cube root of 64 is 4, so that gives me my x here and my 4 here. I use the original sign, which was a subtraction sign in between them for my binomial. And now my trinomial. I square this term. I square this term. And I multiply them together and take the opposite. All right, let's try one more. So here, I know that 3 is not a perfect cube, and I suspect this number is divisible by 3 because 1 plus 2 plus 9 gives me 12, which means that number is divisible by 3. So I'm going to divide it by 3. 1,029 divided by 3 is 343. So when I take out my 3, I get x cubed plus 343. Now, you probably didn't have that memorized, that 343 is a perfect cube, but it is. So what number raised to the third power is going to equal 343? Well, we've already seen that, let me go back. We've already seen that 3 cubed is 27, 2 cubed is 8. We saw that 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. So if you're thinking maybe it's 7 cubed, you would be right on the money. So the cube root of 343 is 7. 7 times 7 is 49, and 49 times 7 is 343. The cube root of x cubed is x. So now we're ready. I'm going to have my 3 out in front, binomial, trinomial. I'm going to take the cube root of my first term and the cube root of my second term, so my x and my 7 go here. The original sign in the problem is the sign in my binomial. And now I'm going to create the trinomial. To get the trinomial, I'm going to square this term. I'm going to square this term. And then for the middle term, I'm going to multiply and take the opposite. And that's it. So again, you don't have to memorize the difference of squares the difference of squares you should know. You should be able to use these patterns given in general form with A and B to determine what the factored form of a sum or difference of cubes would be.